Hello everyone, hope you are doing well. Welcome to the online platform Civil Technobricks. Guys, here we will tune for the instantaneous decoding of conceptual knowledge in the field of civil engineering, where study elaborates decoding the earth to build a better world. Today, we will go through the core concepts related to the industrial applications of various rocks in the view of civil engineering, where the rocks are utilized in the industrial applications with reference to the procedures like extraction, calcination, clinker formation, pulverization, and many more with reference to the usage. So, limestone, chalk, and shale, these are all the primary sedimentary rocks. They are used as a raw materials in the chemical manufacturing. During the calcination procedure, at the temperature of 1450 degrees Celsius, the carbon dioxide is released and chemical reactions produced in the cement clinker. Whereas the clinker formation with gypsum to produce Portland cement, and which is useful in the most important concrete construction. With reference to the civil engineering point of view, these all type of rocks are most valued material for the construction where their chemical composition rather than their load bearing strength is considered. So sedimentary rocks in this industry are mined strictly for their chemical composition, not their physical load bearing strength. So with reference to these four procedures, the whole limestone type of rocks are they get heated up to the 1450 degrees Celsius temperature, where which evaporates that CO2, and that whole procedure is for the clinker formation where calcium carbonate plus silicates fuse into synthetic binding agent, that is a useful for pulverization process at the end, where gypsum added and mild to ultra fine powder, that is a cement manufacturing. Means this chemical transformation shows that the formation of Portland cement from the limestone type of rock under these four types of procedure. Next one will be the geological blueprint of India, where economic rock zones are marked. There are four types of zones: eastern corridors, southern shield second, and vast sedimentary reserves. So vast sedimentary reserves where limestone marble type of rocks are available, then fuels the cement and architectural cladding industries. For that purpose they are used. Southern field is divided into two parts: southern shield where massive igneous reserves which have the granite basalt type below to the earth surface, that is Kerala region, which drives major structural construction, whereas the West Bengal and Assam southern shield where peninsular India region, Rajasthan and Andhra Pradesh region. Next one will be the eastern corridors near to the Himalayan ranges, where resource rich zones, that is coal, iron bearing rocks, which powers heavy metallurgy and manufacturing ingredients. So this geological blueprint of India, which divides the whole availability of rock beneath to the earth's surface with reference to that economy. India's sedimentary rock region contain large reserves of limestone and marble, which support cement and cladding industries. The southern shield, which contain abundant granite and basalt, which are extensively used in structural and infrastructural projects for the construction point of view. With reference to eastern mineral rich region or eastern corridor, which provide coal and iron bearing rocks that support manufacturing and industrial growth. Next one will be the distortion of rocks resources, which strongly influences regional construction activities and the economic development, where the geological blueprint, which is most important for the economic growth of the whole country on the basis of material manufacturing, chemical composition, and its characteristics like compressive strength, brittleness, hardness, and many more. Next one will be the metamorphic specialist, that is marble and slate, that is exploiting anisotropy, basically marble and plasticity, where slate and cleavage. Here, the marble exhibits plastic deformation under high pressure, as explained, that strain on the x-axis, stress on the y-axis, making it highly workable for decorative and architectural applications. So marble rock, which is most important nowadays in the civil engineering domain, marble is widely used for flooring purposes, wall cladding, monuments construction, and interior finishes, everything. Next one will be the slate, which develops strong cleavage planes due to metamorphism, allowing it to split into thin impermeable sheets, where roofing tiles, wall coverings, and moisture resistant applications are major engineering uses of slate type of rocks. Here, the slate and marble most important types of metamorphic rocks, which are rarely used in civil engineering for roofing tiles, electrical switchboards, billiard tables like construction of slate and cleavage, whereas the sculptural aesthetics and interior cladding point of view, marbles are selected. Of rock will be the quartzite, which is the high strength rock. Quartzites consist of tightly interlocked quartz grains or molecules, we can say that, which resulting in very high compressive strength like 1800 to 2600 kilogram per centimeter square. Its dense structure provides excellent durability and resistance to abrasion and weathering action. Despite its strength, quartzite is brittle and may fall suddenly once its yield limit is exceeded, as explained in the graph, where brittleness or fracture healing on the x-axis, where durability and intrinsic strength on the y-axis. As we increasing the healing effect, initial level it directly proportional to the durability or the strength, but at the end it may get kraken, which gets the yield point is reached. So it is widely used in railway ballast, road aggregates, and higher wear and tear construction materials point of view. These railway ballast, extreme abrasive environments, specialized high wear aggregates, these are all the applications, so that due to its compressive strength or high tensile strength and durability. Next one will be the silicon sources. They are most useful for the computer industry point of view, where the quartz rich rocks provide silica, the primary raw material for silicon production. Through the high temperature refinement or metallurgical grade refinement, silica is converted into ultra pure silicon wafers used in the electronics domain. Silicon forms the foundation of computers, communication systems, GPS devices, and modern surveying technologies. Moving towards the global point of view, the global technology infrastructure, which depends entirely on the extraction of that ultra pure quartzite molecule. These rocks form the fundamental physical layer of all computing, solar panels, and telecommunications, where civil engineering point of view or domain, they are increasingly depends on the silicon based technologies for GIS purposes, remote sensing activities, monitoring and maintaining the smart infrastructural development. Next one will be the industrial geology point of view, usage in the medicine, fertilizers, and chemicals. These type of rocks are most important. For example, salt diapers, from when beyond salt masses move upward and create structural traps within rock formations. Valuable industrial minerals such as sulfur, halite, and potash accumulate within these geological structures. Sulfur is important for pharmaceuticals and chemical industries, while the potash is essential for fertilizer production. So, understanding these geological formations, which is most important for resource exploration and engineering geology investigations purposes. Here, the sulfur, which trap commercial deposits essential for pharmaceutical and sulfuric acid in the orange color, nearby to the halide structure, which is extended directly from the core of the chemical processing, which is in the white color. At the uppermost portion, there will be limestone, gypsum, and anhydrite, which is the cap rocks. They provide the capping towards the halide structure. So the mechanism, which is the buoyant plastic salt forces its way upward or move upward under the high pressure, which create impermeable structure which traps for valuable chemicals extraction. Moving towards the synthesis and engineering applications of rocks, the descriptive part or summarized part, where basalt and quartzites, which provide high compressive strength and preferred for road construction, railway ballast, and dynamic load bearing structures. Limestone is valued for its chemical reactivity and it's extensively used in cement manufacturing and building cladding operations. While slate type of rocks exhibits planar coverage, which is ideal for impermeable roofing and sheet applications. Granite supports dam foundations and heavy engineering works. So important geological concepts for civil engineering point of view, they include that the compressive strength, anisotropy, joint spacing, diaper, and cleavage, as these properties which control the rock behavior in construction projects and its execution. So compressive strength, which is the resistance to pushing forces, dictates load bearing capacity. Anisotropy, where varying physical properties dependent on the direction of applied stress. Joint spacing explains that the distance between natural fractures and which dictates the mass rock behavior. Diaper, which is nothing but a buoyant, that is mobile core of rock like salt, piercing overlying structure or strata. And at the end, that is the cleavage, which is the tendency of rock to break cleanly along parallel planes. Stay tuned, guys. Happy learning.